In this video, I will walk you through some basic triangle congruence proofs. I've given you a bank of reasons that we will refer to as we work on these proofs, but I really want you to focus on this little box of reasons right here, because in the end, we have 5 ways to prove that triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. So these will guide us through the proof. Problem number 1. Let's start with the given. So we are given that angle B and angle D are right angles, and I've already filled that in for you. Whenever you are told that two angles are right angles, well, first of all, go ahead and mark that in the diagram with little boxes. So angle B and angle D are right angles. But in order to ultimately use a reason like side, 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 or side, angle, side, we need to write that something is congruent to something. When you have two angles that are right angles, they are automatically congruent. So the very next thing you're going to write is that angle B is congruent to angle D. And you can just say right angles are congruent. Next, we are given that C is the midpoint of segment AE. So I really want you to focus on segment AE, which is right here. So of course, if C is the midpoint, then that means that this segment is congruent to this segment. And that's the next thing we need to write down, is that segment AC is congruent to segment CE. And that is the definition of midpoint. So whenever you use the midpoint to say that the two sides are congruent, that's going to be the definition of midpoint. So what do we have so far? Do we have enough information to prove that these triangles are congruent? No, we only have 2 pieces of information. For all of these, well, except for hypotenuse, leg, we need 3 pieces of information: side, 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 angle, side. Is there anything in the diagram that we can mark automatically just because of the way the picture looks? Well, in general, there are 2 things that we can mark automatically. One of them is if there's a shared side. So for example, if I have 2 triangles that share a side like this, you can automatically mark the shared side because that side will be the same for both triangles. The other one is vertical angles. So vertical angles are the angles that you get when you have 2 intersecting lines, like an X. So vertical angles are angles like this angle and this angle. And vertical angles are always congruent. So if you see either of these 2 things in a picture, you can mark them automatically, either a shared side or vertical angles. So look at this diagram. Do you see either one of those things in problem number 1? So hopefully you see that we have vertical angles right here and right here. And I've sort of given it away by filling in the reason for you that vertical angles are congruent. So let's go ahead and state that this angle is congruent to that angle. Here's a common mistake I need you to avoid. A lot of students will try to name these angles using the single letter C, and they will say that angle C is congruent to angle C. No, boo! This is no good. because you're referring to two completely different angles. They cannot have the same name. To avoid this problem, you need to use the three-letter name. So the angle on the left, we can call this angle ACB, for example. So I can say angle ACB is congruent to angle. And the angle on the right, I could call this angle DCE, for example. So this is congruent to angle DCE. You cannot just say angle C is congruent to angle C. And so when you're saying that vertical angles are congruent, the reason is simply that vertical angles are congruent. Now, looking at the picture, you can see we have enough information to prove that these triangles are congruent. Think about whether or not this will be side, 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 side angle, side, etc. I see that we have right triangles, so I always quickly ask myself, will this be hypotenuse leg? I am noticing that we do have the hypotenuse right here. And in fact, please understand, for now, I'm just focusing on one triangle at a time. So just look at the yellow triangle. We have the hypotenuse, but a leg means another side of the right triangle. We don't have any other sides. So we have the hypotenuse, but we don't have a leg. So it's not going to be hypotenuse leg. So we need to look at this as just a regular triangle. I notice that we have two angles and a side. So that means the reason will either be angle, angle, side, all right, two angles and a side, or it could be angle, side, angle. It all depends on whether or not the side is between the two angles. If it is, then it'll be angle, side, angle. However, if the side is not between the two angles, then it's an angle, angle, side situation. So the question is this marked side between these two angles? No, it is not. Here's one angle that's marked. Here's the other angle. This is the side that's between those two angles, and that is not the side that is marked. So, because the marked side is not between the two angles, this is angle, angle, side. So the reason will be angle, angle, side. Now we need to finish this off with a triangle congruence statement. So triangle ABC is congruent to triangle what. You have to match up the corresponding angles in the same order. So this can sometimes be tricky. Angle A is first. So you can probably see that angle A corresponds with angle E. Right? The yellow triangle and the white triangle are sort of rotations of each other. So A corresponds with E, so I'm going to do E first. Or if you want to go by the markings, notice that angle A is the only angle that is unmarked. Angle E is the only angle that is unmarked. So it's another way to tell that those are corresponding. Angle B in the yellow triangle corresponds to angle D in the white triangle. You can tell because of the 90-degree mark. So that we have ED, so that only leaves angle C. And you can see that the yellow angle C is marked congruent to the white angle C, so that makes sense. So you have now completed your first proof. All right, it's not too bad. Let's do 3 more problems. Okay, looking at problem number 2, let's start with the given. We are told that segment AE and BD bisect each other, and I've written that down in the proof. Okay, the statement, of course, the reason is given when you're just writing down the given, but that is going to lead to something congruent to something. So don't forget that bisect means to cut in half. So focus on the segments that are being mentioned here. So AE is this, and then BD is this. So if these bisect each other, that means they cut each other in half. So that means that, for example, AC is going to be congruent to CE, all right, because it's being cut in half. Let's go ahead and write that down. Segment AC will be congruent to segment CE. But of course, the other segment, the purple segment, is also being bisected. They bisect each other. So that means that segment BC will be congruent to segment CD. Let's write that down. Segment BC is congruent to segment CD. So when you want to think about what the reason will be, sometimes it's helpful to look at the previous statement. So we just said that these two segments bisect each other, and then all of a sudden we say that these things are congruent. Well, that will be the definition of segment bisector. All right, the previous statement said bisect. The next reason is going to mention bisector. This is very common. Okay, do we have enough information to prove these triangles are congruent yet? Not quite. We just have two sides. All right, we need three pieces of information. Is there anything else in the triangle that we can mark automatically? Remember, the two things we can mark automatically are shared side, vertical angles. Do you see either of those in this picture? Hopefully you can see that we have vertical angles here and here that we can mark automatically. So by now you've learned that we cannot just name these angle C is congruent to angle C. You have to use the three-letter name. So we can say angle ACB is congruent to angle, and we can call this one on the right angle DCE. Angle DCE. So these are vertical angles. When you are saying that vertical angles are congruent, guess what? That's the reason. You simply say, hold on, that wasn't a very good E. I'm going to abbreviate. So vertical angles are congruent. All right, that's what you put for the reason. Now we have enough information to say that the left triangle is congruent to the right triangle. I'm going to focus on this yellow triangle as I decide what the reason is. So I'm noticing that we have two sides and an angle. So that means this would either be a side-side angle situation, or it would be a side angle side situation. We are really hoping that is not side-side angle, because side-side angle actually does not prove that triangles are congruent. And we're doing a proof, so we would be stuck if it turned out to be that one. So it's probably going to be side angle side. But the way you know for sure is if the angle is between the two sides, then that's side angle side. So is the angle that's marked between the two sides? Sure, because here's one side that's marked congruent, here's the other side that is marked congruent, and look where they meet. They meet right here at the angle that's marked congruent. So the angle is between the two sides. So the triangles are congruent by side, angle, side. Now it's time for the triangle congruence statement. We need to make sure that we are matching up corresponding vertices in the same order. So we're starting with angle A, which is right here. Notice that angle A is across from the double side. Look at the white triangle. Angle E is across from the double mark. So that means that angle E is the corresponding angle. Next, we have angle B. Notice that angle B is across from the single mark. Angle D is across from the single mark. So that's going to be the corresponding angle. And that just leaves angle C. And of course, angle C from the yellow triangle is congruent to angle C from the white triangle. So those will definitely be corresponding. All right, so that's our second proof. Let's do two more. All right, in this picture, we are given that segment AB bisects angle CBD. And I've gone ahead and written that into the proof, the statement, and the reason will be given whenever we're just writing down the given. But we need to turn that into a congruent statement. We need to turn that into something is congruent to something. So don't forget that bisect means to cut in half. I want you to focus on the second part right here. This angle is being bisected. This angle is being cut in half. CBD. It's really important that you focus on the correct angle. So I'm going to trace from C to B to D to draw your eye and highlight for you that this is the angle that is being bisected. This is the angle that's being cut in half. So that means that this part of the angle is going to be congruent to this part of the angle. So that's what we will put on the next line. Angle is congruent to angle. You definitely have to use the three-letter names for each part. All right, you can't just say angle B. All right, this is two different angles. So for example, we could call the first angle angle CBA. So I can say angle CBA is congruent to. And we can call the second angle angle DBA. Angle DBA. Again, if you want to know what the reason is, it's often helpful to look at the previous statement. If the previous statement says something bisects something, then the reason is going to be something bisector. And we're talking about angles, so it's definition of angle bisector. Okay, but the previous statement gives you a hint about what the reason will be. There is another given. We were also given that angle C is congruent to angle D. So let's go ahead and mark that in the picture. Angle C, I'll use a double swoop since the single swoop is already taken. Angle C is congruent to angle D. So the reason, of course, is simply given. Do we have enough information to prove that the triangles are congruent yet? It's not quite enough. All we have is angle, angle. That's not a thing. Is there anything else that we can mark automatically? Well, remember, there are two things we can mark automatically: shared side and vertical angles. Do you see either of those things in this picture? Sure, there's a shared side right here. So we can go ahead and mark those as congruent. So when you have that shared side, the statement is segment AB is congruent to segment AB. You're just saying that the shared side is congruent to itself. Whenever you have this sort of silly seeming statement where you're saying that something is congruent to itself, that is called the reflexive property. All right, I'm going to abbreviate slightly and put prop. Okay, the reflexive property. That's where you say that something is congruent to itself. Now we have enough information to prove that the two triangles are congruent. Let's color one of them yellow to differentiate and focus on the yellow triangle. So I'm trying to decide which of those 5 reasons proves these triangles congruent. Is it side, 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 side angle, side, or what? I'm noticing, looking at the yellow triangle, we have 2 angles and a side. So that means the reason will either be angle, angle, side, because that's 2 angles and a side, or it could be angle, side, angle. This is also 2 angles and a side. The difference is, if the side is between the 2 angles, that will make it angle, side, angle. If the side is not between the 2 angles, then it's angle, angle, side. So is this double marked side between these 2 angles? Well, no, it is not, because looking at the yellow triangle only, here is one angle that's marked. Here is the other angle that's marked. This is the side that's between those 2 angles, and that is not the side that's marked. So the marked side is not between the 2 angles, so that means this is angle, angle, side. Now it's time to finish it off with the congruence statement. Triangle ABC is congruent to triangle what. So be very careful. A lot of students will get this wrong. So we need to match up the corresponding angles. So we're starting with angle A. So angle A in the yellow triangle is going to correspond with angle A in the white triangle. That won't always be true. It won't always be the same letter. We can tell because angle A is the only angle that is unmarked. All right, it's the only blank angle. And if you look at the white triangle, same thing. Angle A is the only blank angle, so you know that those correspond. The yellow angle B has a single swoop. White angle B has the single swoop. So B is going to correspond with B. And that only leaves, what does that leave? In the white triangle, that only leaves angle D. But it makes sense because the yellow angle C, which is where we are, has the double swoop. So that corresponds with the white angle D. Okay, so another proof under our belts. One more to go. So here's the last proof. We will have to do this one all by ourselves. This one's completely blank, but you've got this. You've trained for this. You are ready for this. Let's start with the given. Angle BAC is congruent to angle DBA. Let's just go ahead and write that down. Angle BAC is congruent to angle DBA. So of course the reason will simply be given. Now let's mark that in the picture. So angle BAC is that angle right there. So let's go ahead and mark that. And then angle DBA. So DBA is this angle down here. So let's go ahead and mark that. Okay, so far so good. What else is given to us? Next, we are given that segment AC is congruent to segment BD. We love having things that are congruent. That will lead us to like side, 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 or side angle, side. So let's definitely write that down, BD. Okay, that was also given, so we can simply write given for the reason. And now we will mark it in the picture. So here is segment AC, and here's segment BD. We will mark those the same. So we're out of givens. We do not yet have enough information to prove that these triangles are congruent. We only have 2 things. Is there anything else we can mark in the picture automatically? there are only two things that we can mark automatically: shared side and vertical angles. Do you see either of those two things in this picture? Of course, you see the shared side right here. So we can go ahead and mark the shared side. The shared side is segment AB. So that will appear as the statement AB, segment AB, is congruent to segment AB. When you have a shared side, you simply say that the shared side is congruent to itself. You need to memorize that the reason when you say that something is congruent to itself is the reflexive property. All right, you just have to memorize that. Reflexive property. But look, now we have enough information to prove that these two triangles are congruent. Let's colorize this a little bit. Let's make one triangle yellow so we can differentiate the two. Okay, for now, focus on the yellow triangle as we try to identify the reason why these triangles are congruent. So I see that we have two sides and an angle. So the reason, the situation is either going to be a side-side angle situation, all right, two sides and an angle, or this will be side, angle, side, which also involves two sides and an angle. Now we are doing a proof, and we know that side-side angle does not prove that triangles are congruent. That's not one of our reasons that we can use. So hopefully it's going to be side, angle, side. Probably it's going to be side, angle, side. But to be sure, let's think about it. Side, angle, side is when the angle is between the two sides. So is this angle between the two sides? Yes, it is, because looking at the yellow triangle, here is one side that's marked. Here is the other side that's marked. And look where they meet. They meet right here at the angle that's marked. So that proves that the angle is between the two sides. And that's why this is side, angle, side. So let's wrap this up with a congruence statement. So we need to say, now we know that triangle ABC is congruent to triangle something, something, something. Now actually this is the part that students get wrong most often. A lot of students can do everything else I just did, but then they lose points on the congruent statement. You need to make sure that you are matching up corresponding angles. So this gets confusing because we have two different angles at A and we have two different angles at B. And some students will assume that angle A will automatically match up with angle A. Sometimes it does, sometimes it doesn't. So when you look at this, you have to think about the yellow angle, and that's what we have, that's what we're talking about here, versus the white angle, okay? And that's what's going to appear right here. So the yellow angle A corresponds with the white angle B, because single swoop, single swoop. So the yellow angle A corresponds with white angle B. So angle A does not correspond with angle A. So just be careful. Now, next we see angle B. So on this side, this is the yellow triangle, okay? And then over here, we are describing the white triangle. So right now we're talking about the yellow angle B. So the yellow angle B is blank, okay? That is going to correspond to the white angle A, all right, which is also blank. So yellow angle B corresponds with the white angle A. Okay, obviously angle D was also blank, but it's pretty obvious that angle C and angle D correspond to each other. Okay, so the yellow angle C clearly corresponds with the white angle D. So that comes last. And that's it. You did it. You did an entire proof all by yourself. Okay, so we proved that triangle ABC is congruent to triangle BAD.